Hello, everybody. Another day, another recorded Zoom interview, this time with a favorite guest from last winter, Skye Cooley, geologist in western Montana. Skye, are you in the Mission Valley? And if you are, what is the weather report this afternoon?
Weather report is snowy with more snow on the way.
Okay, okay. All right. It's really winter there. Thank you. Well, yeah, Skye, you are back. We're not talking Ice Age floods today. We are talking about trying to get maybe the conventional answer about the uplift in the Cascades. When are we going to finally uplift the Cascades to something that looks like a mountain range? And then the second half of this might be exploring an idea that I'm very excited about at the moment, but we'll see if you want to cool my jets on that or not. But let's go ahead, Skye. Do you want maybe some opening comments about how much have you been thinking about the uplift of the Cascades, and do you have some general verbal messages before we maybe look at a couple of images that you have?
Yeah, let's see. So I've been thinking about topography and uplift for a long time, since I was in my 20s. Let's see. So your series, you guys have really talked about rocks and a lot of volcanic rocks, some sedimentary rocks, but mostly volcanic clastic rocks. And so when we talk about the mountain range, the Cascade range, you're really not talking about rocks, right? We don't associate the Cascade range with a rock type or even three or four rock types. It's a hash of all sorts of different rock types. And, we don't even use those terms like in the Rocky Mountains where we say, oh, this is basement, and then this is the Paleozoic and Mesozoic cover sequence, and then there's the tertiary. We don't
Yeah.
even call things basement very confidently in the Cascades, and that's good because it doesn't
Mhm.
really work. And so when we talk about the mountain range, we're really talking about topography. And there's a difference between the amount of rock you uplift and the topographic expression of that uplift. So you
Mhm.
could, in a certain highly erosive climate, you could uplift a lot of rock and never create much of a mountain range.
Mm.
And so those are kind of basic concepts that I think about when I think about the uplift of the Cascades. And then the other side of that more recently is just the work in the rain shadow on paleosols. In the rain shadow, those calcretes are essentially an expression of the rain shadow climate created in the lee of the Cascade Range. So,
Well, let's grab hold of that. That's where we should start then, I think. Most of our viewers have a concept of a rain shadow effect. It's wet in Western Washington, Western Oregon. It's dry in Eastern Washington. And I know that you've got some figures and some work tied specifically to when are we creating enough topography to create that rain shadow effect. Verbally, what's your number? What's your simple takeaway number for when the rain shadow is really in full effect? You don't
my
want me, you don't
number.
want to, yeah.
No, I think from everything I've learned, and if I just said here's what I've learned firsthand, I would
Yeah,
say it's no earlier than 12 million.
12
Yeah.
million years ago.
Yep.
Okay. And let's, hoping I can share a couple of your figures right now. Are they going to show us some of the thinking or
Yeah.
the evidence behind that?
Yeah.
Well,
Let's
then
just look at a compilation of
let's
studies.
go.
Yeah.
Let's go. Okay. So, very excited to do this. And this is a very, you always have such pleasing diagrams with colors. And these are not necessarily our colors for our
No,
series. Uh,
sorry.
but can you help us? I'll try to point out as you're talking here a
Sure.
little bit if we need to point out. This is beautiful. Let's go.
Okay, so on the left side is just I stole this from Gary Smith, a sketch out of his 1988 paper, and then I
Mhm.
added some labels and some arrows and the words. So this is a classic sort of if you learn basalt stratigraphy, you probably looked at a lot of these figures that kind of look like this. And I
Yes.
used it on purpose. I don't like the modern sort of antiseptic ones. I like these hand drawn ones. So Gary Smith's good work on the left. On the
Yeah.
right, it's just a compilation of most of the studies, more modern studies on thoughts about evidence for uplift of the Cascades. And so I've left off stuff from like Bailey Willis and Russell and even Paul Hammond and Steve Porter, but it's
Okay.
represented here by others. So if you just look at the arrows and you say, what were people kind of thinking in terms of when the Cascades begin to uplift?
Yeah.
We see folks talking about 15 million years ago, 15 and a half million years ago, Takuchi and Larson. We see Smiley from, way back in the day talking, maybe 15 to 12 million or 15 to 11. And then we see this whole cluster of different studies using completely different methods and chemistry and geomorphology and structural geology that sort of, you can see it. They cluster somewhere between 12 and 4.5.
Mm-hmm.
And I think the tighter cluster tends to be in that 10 million range. And I think there's evidence for a serious orographic divide developed by 10. It probably kicked off earlier and probably wasn't uniform across the range in Washington, but probably we had a strong orographic divide and at least a developing rain shadow by 10 million years. That's my feeling on it.
We'll come right back to that figure, and you're in there in black. Looks like you were about 9-ish, where your
Yeah.
little black arrow went. Um, I'm thinking of the viewers right now, maybe who've been following along the whole winter, and I think they're surprised by this. I think they're surprised this is so late. This is so young. We're
Yeah.
essentially saying we don't have much of a mountain range, a significant mountain range,
Yeah.
even 13 or 14 million years ago, which is
Yeah.
the tail end of the red time. And that's
Yeah.
what you're saying. We're into brown time. Come on, man. That's what you're saying as well. And that's pretty much
Yeah.
what everybody's saying.
Well, that's what's so cool is you have convergence, right? You have a plate margin that's making an arc for 45 million years. And yet you don't have the expression of a range on the overriding plate until somewhere, in the Miocene, maybe even the late Miocene, maybe even later than that. But it looks like, the late Miocene.
Well, that's
That's a
a head
long
scratch.
time.
That's a
Yeah.
head scratcher, isn't it? I mean, if we think of the Andes, I'm sure people have been spending whole careers thinking about this. I'm thinking about it for the last 3.5 minutes, but the Andes or some of these other convergent boundaries that are seemingly identical to the Cascade volcanic arc, that can't be really young
Yeah,
uplift as
yeah.
well, or maybe it is. I don't know.
Yeah, I don't know. I mean, I think what you're showing us and what like Jeff Tepper's work and a lot of the folks that you've had on is, when we talk about an arc, even your Idaho stuff, when we talk about an arc, what are we saying? We're
Hmm.
kind of using these proxies. Oh, that's granite. That's this kind of granite. So that must be an arc. And then later people go, well, you can form that in other ways. That's not an arc.
Right,
And then you go, wait
right.
a minute. My whole world was based on that being an arc. And now it's
Yeah,
not an arc.
yeah.
Oh, okay. And then these
Okay.
near trench magmas, so you're sort of dissecting what we think we know. And it's great. This is great. This is perfect. This is exactly what science should do, exactly what geologists should do. So we're drilling down.
We're drilling down and it's fun, but we're just assuming, at least I think most of us are just assuming we have some sort of cascade looking range, and we don't
Yeah.
until, younger than 12, as you say. And so, is the next figure going to help us see
Yeah.
what you're looking at to hover in here between 10 and 5? And
Yeah, let's kind of look at a different view of the same kind of idea.
okay,
So just this is how I think. So I always try to draw diagrams that you could actually like write into your field notes, and actually
Mhm.
get something out of them. So I try to make them
Mhm.
as robust as possible, but also cartoony enough to make them fun. So if we look back as far as the Eocene, we know we've got no mountain range and a coastal plain all the way to the Pacific. If we
Yes.
look at the Oligocene, we're kind of in the same ballpark. Warm, wet, or at least flat, and a climate that's not much like ours today. It's only until the Miocene, we have to get all the way to the Miocene until we start coming into something even close to what we have today. And how
Mm.
I've drawn that is that upper part, that upper figure, somewhere around 10 million years.
Yeah.
The Cascades are a low topographic divide, possibly with through-going valleys. So east-west valleys with significant rivers
Mm.
crossing the divide. Now, I don't know if
Mm.
that's totally right, but it makes some sense with the information that's out there. It also is showing that Pacific storms, so wet Pacific storms, track all the way inland across the range into eastern Washington, basically unimpeded. So you're
Yes.
bringing moisture from the Pacific all the way into the interior without a significant barrier.
No rain shadow yet.
No rain shadow, right? And so by 7 million, and these are fuzzy dates,
Right?
maybe this is 9, maybe it's 11, but it's
Yeah.
sometime flirting with the Pliocene, somewhere in the
Yes.
latest Miocene, we see the development of asymmetry. So you're starting to trap storms on the west side, and you're starting to rain out as you move across the range. The mean elevation of the mountains is picking up, and dryland soils and dryland chemistry in the water is starting to show up on the east side.
Hmm.
Okay. And so that would be about the first time I've seen calcium carbonate cements on the east side, is somewhere around that maybe 7 to 9 million years in the
Hmm.
stratigraphy.
Mm-hmm.
And then by 4 million, I think everybody agrees that once you're, at the end of the Pliocene, you're kind of the Plio-Pliocene boundary, you've got a fully developed mountain range with a strong orographic barrier. Storms are being trapped much like they are today on the west side. You're raining out your oxygen isotopes, and you've got a full rain shadow developed to the east. And so that's all this is saying. The dates don't really matter. They're somewhere in this ballpark, but it's the concept of saying sometime in the Miocene, sometime in the Pleistocene, and then the Pliocene sort of in the middle as a more similar to today, but not with quite as high a range or glacial development as today.
Very good. So you're coming at this from an angle of thickness of calcretes in eastern Washington. That seems to be a new approach to back up this chorus of people who are saying rain shadow establishing younger than 10 million years ago, let's say. And to confirm what I think you taught us all over the last 3, 4 years, you need a real arid environment to get those calcretes. You can't get the calcretes if you have a low Cascades.
That's right.
What are some of the other, just off the top of your head, you've been doing a lot of reading about this over the years. What are other approaches that geologists have been using to propose this idea of an uplift of the Cascades younger than 10 million years?
Well, there's several. Matt Cohn at Boise State does isotope geochemistry, and I'm not sure where they found it, but it was an ungulate tooth that they found buried in a paleosol sequence, and they cut it open, did their chemistry on it, and were able to figure out that that animal was eating plants that correspond with a certain climate, and that climate was a dry climate. And so knowing the age of the strata they were working on, knowing the chemistry of the tooth, they were able to make the leap that just says the Cascades were risen by the time this tooth fell out of that animal's head. Others in similar ways, people use groundwater chemistry, compare it to a standard, and then can make some leaps towards burial and depth and heating and make some other leaps. It's a little dry,
Yeah.
but chemistry gets you a long way, and isotopes of oxygen and carbon get you a long way in this story. They essentially give you paleoclimate. So you've got paleobotany as well, which has been around a long time, and a lot of people sort of pre-World War II and then through the mid-century, a lot of people were finding, if you look at the Vantage interbed, you were in a warm, wet environment in the
Right.
Miocene. But as you move into the Ringgold and the Pliocene, you're starting to pick up the change between, you know, uh, savanna type botany, plant community, into a dryland community. And so that shift is recorded sometime in the Ringgold around 5 million years. Uh, Fossils of animals is another one that people have used. Gustafson and Smith and a lot of other people in the Ringgold, especially have, defined the animal community that way. There's others, geomorphology, Eric Cheney, structural geology, cross-cutting relationships. Sort of if you're dealing with tilted things like the Columbia River basalts that didn't start out tilted, well, the tilting is younger than the basalts, and if you know the age of the basalts and the age of the tilt. So there's 4 or 5 different approaches, maybe more than that, half a dozen approaches that people have used to get to answers or a cluster of answers.
Well, God bless you. You just teed that up on a silver platter. The second half of this, I want to talk about the flood basalts, the Columbia River basalt group, the German chocolate cake. I think in this current winter series, we're going to call them the Yakima basalts. Paul Hammond and others were calling them the Yakima basalts. It's all the same thing. So, unless you wanted to say a couple final thoughts about that, I'm ready. I'm ready to kind of go to part 2 of this discussion, which is about to happen. I don't know, Skye. I think there's a chance that over the next week or so, I'm going to get deeper and deeper into this concept of, did the Columbia River basalt lavas cross the Cascades because the Cascades were so low, so late? And then they're like, obviously not. You can't find the Columbia River basalt lavas in the high Cascades. You can't find the Yakima basalts in Western Washington. This is almost like last couple of winters. I'm reading this stuff from 50, 60, 70 years ago. These guys are talking like it's an obvious thing that those flood basalts cross the Cascades. So I don't know how far I'm going to go into this. You might talk me out of it. I might talk to some other folks in the next week, but I don't know. Late in the alphabet, I might just lean heavier and heavier into this because we have been flirting with this uplift thread, and now we hit it right on. So before we go I want to read a couple things to you that you haven't heard in a while, maybe ever, but can we just get something verbal from you right away? I know this is more my Jones now than yours, but if everybody...
go ahead.
No, please.
When I think about the Columbia River basalts, they provide a Miocene datum, right? So
yes.
You've got control on age, but it's not quite young enough, right? We need basalts at like 7 and 6, and they aren't really, there's some in there, but they're not around, right? We don't have them nearby. We're still in that 15, 16, 17,000 years.
Let's just pick a number, 17 to 16. That's when we have these massive Grand Ronde lava flows that are heading straight for the Cascades. And you're right.
We know they're tilted. We know they're eroded. We know they've been, if the Cascades is thought of as sort of an arch on the east side, the basalts are tilted. So we know the arch is younger than the basalts, right? We know that. Are there remnants of basalt all the way at the peaks? Like on Mount Moran, you have this beautiful, in the Tetons, you have this beautiful skiff of flathead sandstone on the top of this basement rock. No, we don't have those basaltic remnants all the way across the Cascades, but maybe there's other evidence that people could use.
Okay. So I'm going to read basically stuff that you just said, but I want to read it from 50, 60, 70 years ago. And viewers, before I do that, before we lose you here, all through this winter, we've been saying, well, it's green Ohanapakash. We're down at sea level. Okay. It's red time now. These next couple of shows, Paul Hammond and all the Fife's Peak stuff, I think we're still pretty low. Now we're 26. We're approaching 17 million years ago, which is this brown time. It's called brown for a reason. The brown basalts of eastern Washington are coming towards the Cascades. We're still fricking low because, as you heard earlier in this conversation, nobody, is that right, Skye? Nobody's saying there's massive uplift in the Cascades younger than 12. I just want to say that one more time. Like, nobody's saying there's a major mountain range earlier than these flood basalts.
No, certainly not 15. If you want to put an absolute, nobody says it's not older than 15. Yeah.
And here's why they're saying that, viewers. So let's go to this. And Skye, just please bounce off whatever you hear that interests you, and I'll stop and kind of go. So I'm going to go to Bates McKee, 1972, one of my favorite old textbooks. And I want to include the fact that in the front piece, he's saying to the late J. Hoover Mackin, colleague and friend. And so I've got Mackin as well from 1947 writing this stuff out. I mean, I know this thing was printed in 65, but I think most of the text is from 47. Let's just read this. Skye, you cut me off anytime you want to expand on this, but I just literally read this in the last hour before we cranked this Zoom call up. Rise of the Cascades. Let me get my pointer. Daddy's excited. God damn, this is... All right. The rise of the Cascade Range. The modern Cascade Range has been built by the late Cenozoic uplift. The nature of the uplift is most clearly seen in southern Washington and northern Oregon, where the CRBs has not been stripped from the range by erosion. Right off the bat, they're implying that these flood basalts are crossing the Cascades. Exceptionally fluid lava flows. The top surface of any layer in the German chocolate cake was essentially horizontal after flowage had ceased. Any slope that we can see now on the top of a basalt lava flow, part of the flood basalts, reflects post-Miocene deformation. In other words, folding or faulting younger than 17 million years ago. If we go to the Columbia Gorge between Washington and Oregon, we can find those basalts. There's a more than 2,000 foot thick section of CRBs, German chocolate cake, that climbs gradually westward from eastern Washington. It crests out right in the heart of the gorge at Cascade Locks, and then it starts to descend towards western Oregon and western Washington. The total structural relief of the arch, almost 3,000 feet. In other words, the axis of the Cascades has been raised this amount since 17 million years ago. Undoubtedly, this is close to a minimum figure for the Cascade Uplift. And since the region around the Columbia Gorge is the lowest part of the Cascades, we can expect it's more extreme to the north. Basalt flows near Ellensburg rise westward into the Cascades about 8 degrees to an elevation of 7,000 feet elevation, about a mile higher than those same flows as you go out east towards Skye Cooley country. Furthermore, the Wenatchee Mountains are far to the east of the axis of the actual Cascade Arch, thumbs down for some reason. Unfortunately, erosion has stripped the Columbia River basalt from the axial region of the Cascades. Unfortunately, erosion has stripped the flood basalts from the axial region of the Washington Cascades. Now, this has always been in the back of my mind for 35 years, from Robert Bentley to talking to Eric Cheney to talking to Ralph Hagerud and others. Same for you? This is not a new concept that these old timers were talking about this relationship.
Yeah, post-Miocene has always been the story. Post-Miocene uplift of the Cascades. It's always been there since 1900. I think when you talk about the crest of the Cascades, Mitchell and Montgomery is the paper 2006 to read, because it shows that, here's the Cascades were east and west, and that the topographic divide is here, but the drainage divide is well west of there. And so the highest peaks are actually east of the drainage divide. And that's important in the way they make their arguments. But it is important to understand that there's some asymmetry in those things. So we talk about the crest of the Cascades. You could talk about the highest peaks, or you could talk about the drainage divide, but those are very different things.
Oh, okay.
Anyway, probably minor.
Well, here's my take on it.
Yeah.
Go ahead. Please go. Please go. You got something else.
Just thinking about that Bailey Willis book. That was the first book I ever picked up in geology, for the first paper I ever had to read or write for a college class. And I remember just going, whoa, Look at all this stuff. How do people even know this? Anyway,
Right.
Bates McKee. Yeah. No, I didn't have any more. Keep
Okay.
going with what you're talking about.
Well, I want to read a little bit of Mackin as well, but I think this is a kind of a workshopping second half of this thing where I'm just trying to find narratives that seem to work in how we will explore this and how deeply to go.
I had a couple points on the basalts themselves, but when you get to that, we can talk about
Please, right now. I
it.
won't
Okay.
forget.
Well, I just wrote down some things that I was thinking, waiting for this to start. And okay, so the Yakima folds are oftentimes sort of conflated with the rise of the Cascades. And I think it's important to kind of separate those in our minds. And sometimes that's hard because a lot of compression involves the same manifestation. Folds are manifesting because of compression at the margin.
Yeah.
But it's important to recognize that you're separating some. There's a lot of literature on the Yakima folds, not so much on the Cascades themselves.
Right.
The Cascades don't have range bounding faults, right? We don't look to range bounding faults to describe the uplift of the Cascades, which is a little weird for most mountain ranges, especially with a Rocky Mountain perspective. You know, most mountain ranges kind of have range bounding faults, the Wind Rivers or the Wind River thrust. So we're looking at sort of arching and folding and intrusion and kind of a messier process. With respect to the basalts, when you look at those maps that people make of each basalt flow, so the Saddle Mountains basalt or the whatever basalt, you see that a lot of them become these narrow ribbons and are following paleotopography, as you've discussed in previous years. And my thought is if basalts flowed through the Cascades in an older period and that those have since been eroded, then you should see those same patterns, at least to the point of like Yakima, Ellensburg, Sela. We should see that same thin linear entrant into the mountains. And I'm not sure we do. Maybe it's been stripped, maybe it's been folded and faulted away and eroded. Fine. But I think you would want to see something in the map pattern of basalt flows that showed you that there were paleo valleys running west. And to go along with that, as well as whatever remnant basalts are on the west, or on the east flank of the Cascades today, should show intercanyon flow patterns, right? That radial crack pattern that says you're flowing in canyons. And if you see that, well, great. If you don't see that, well, that's telling you something. Maybe those canyon filling basalts have been eroded away a long time ago. But those are kinds of things that I think about. You should see an entrance pattern from the east, and you should see intercanyon flow patterns within those basalts.
Okay, let me bounce off of that. This is great. I think we're good. By the end of this conversation, we'll have 3 viewers, but I don't care. Like we're not setting up the context for any of this. No. This is exactly where I want to go, but I'm gonna pack it
Calcrete and only have one.
So my reaction to that, interesting. That's my first reaction. Second reaction is, I think I'm mostly thinking about the Grand Ronde time for this crossing of the Cascade scene, and the volume, as I'm imagining it, the volume of those Grand Rondes are so biblical that we don't give a shit where the drainages are. We're just overwhelming everything. And the paleo drainages and all that crazy, beautiful work, Terry Tolan, Rydell, and others. Yeah, but those volumes, we've already kind of shut down on the volumes of those mafic magmas. And so I wonder if it's worth parsing out the Grand Ronde time versus the younger Wanapum times and the Saddle Mountains flows where nobody's talking about crossing the Cascades with those piddly guys. The other thought there is that I think everybody who knows the geology of the Northwest knows that those flood basalts are coming through the gorge, as we just read, more than 2,000 feet thick.
Right, making it to the beach. Yep.
And I think I've always I had the image that, okay, I know the Cascades are low and that there was a kind of a proto Columbia River Gorge, some sort of major passageway that we still have today. And most of those CRBs are kind of naturally funneled that way. But I didn't give any thought to the elevations at that time up by Rainier or up by
Mhm.
Snoqualmie Pass. And I think that's the crux of the matter for me.
Yeah.
Like, I don't even care really that much. Sorry, Gary Paul. I don't even care about up by Glacier Peak or farther north. I'm
It's
just,
all lost. Yeah.
I'm imagining south of Snoqualmie Pass, but north of the heart of the Columbia River Gorge,
Yep.
and that area is still so freaking low. That's the time. So I'm basically okay. I'm going to try something.
Yeah.
I'm going to try something. This is fun. I second camera. Concentrate now. Concentrate. So I got as far as this before you showed up on the Zoom window, and I'm thinking to myself, okay, so nobody's saying this, but if you're just a rookie thinking about the Cascades, you go, well, by the time you get to 17 million years ago and you get these fissures in eastern Washington and northeastern Oregon, and let's say these are just the Grand Ronde flows, just the Grand Ronde flows, big and thick and lots of volume. Maybe you just assume that the Cascades are big by that point, and so we have these flows. They're watery, they're paleo-horizontal, but they just kind of pinch out as they head to the foothills of the Cascades. And then I think we just read from Bates was that if we have something similar, but we do have a passageway through the low Cascades, not the high Cascades, but the low,
Hmm.
then we can get those Grand Ronde flows to come right through. And then the point of Bates's passage is that post 17, they've been arched up
Hmm.
and 2,000, almost 3,000 feet of structural relief. I'm interested, though, in what this scene looks like before you enter the heart of the gorge uh, in the area of Yakima, Washington, or
Hmm.
Ellensburg, Washington. And
Yeah.
I think that what we have is that,
Yeah. That abrupt end.
like Table Mountain, just north of my town, or Divide Ridge near the Goat Rock, south of Rimrock Lake. I think this is the stunning thing that I need to somehow try to capture visually or with some key
Mhm.
papers or something. But then if we get to this, I don't think anybody's saying there's that on the other side.
Yeah.
And
Well,
then we
yeah, nobody's saying that. I think Eric Cheney has hinted at that
hinted
over the
at that.
years. Yeah. But I don't know if there's evidence of CRBs in Puget Sound. Yeah.
So even if there's not truly 17 million-year-old flood basalts to match up in Western Washington, what stratigraphy does exist
Right.
17 million years ago over here at Chehalis or something to say those basalts were in the neighborhood if they really did cross over the Cascades before they were uplifted and totally eroded.
Well, basalt's distinctive enough. You'd see it. People would see it. Geologists would know. I'd be shocked if CRBs were sitting there in any great volume and
Even
nobody's
in this,
seen them.
even in the subsurface, you'd think we would have seen it by now.
Somebody would have. I mean, that would pretty alert. People would be like, "Whoa, we need to know more about that." So if it was all subsurface, maybe there are boreholes that hit basalt, but I don't know. Would
But what?
I
But if it's a bunch of sedimentary stuff that's 17 million years old in the Puget Lowland,
doesn't
uh,
need to be basalt. You could just look for a proxy of a mountain range, right? So high energy gravels, conglomerates shed west off of a highland, anything that looks like the proxy of a mountain range sitting there in the basin. That's what I would be keying in on. If you found basalt, whoa, that'd be great. Publish tomorrow. But
well,
you're kind
I'd
of
want
looking for the signal of a mountain range, right? Of an abrupt topographic change.
signal of a mountain range, but now, Skye, I'm getting disappointed because if I just have an uplifted mountain range, I don't think that's a headline. we know there's uplift,
Yeah.
and
But
conglomerates or
when?
other things, but I'm greedy now. I want conglomerates of CRB, I
CRV,
guess.
right?
You
Yeah.
know, like to say that this concept, it may be pretty quick before I get off of this, but
If you
I
could walk
wonder.
the beaches of Puget Sound and do pebble counts and know you weren't getting Canadian basalts in there, that'd be cool. But you got all these glaciers dragging across
Oh yeah, the
basalts
glaciers, right.
of Vancouver Island. I don't know how you isolate a signal of basalts in Puget Sound other than encountering basalts.
So let's say you find a bunch of basalt clasts in Puget Lowland
Yeah.
uh, from 17 to 16 million years old in sediments. And then you're like, okay, well, I'm 17 million years ago, and I've got a bunch of basalts here, hypothetically.
Yeah.
Well, then they could be Silesia basalts, I guess, coming in from the west, or they could be CRBs that were truly from the east. Like geochemically, I guess would be the only way to tell the difference.
Well, what
I don't
about
know.
what about still in the Cascades? What if you don't need
What
to go
about
that far
still in
west?
what
Okay,
about
so
still in the
there's
Cascades?
that Steamboat Mountain, right? There's supposedly CRBs between Mount St. Helens and Mount Adams.
Okay.
There's a peak up there called, it's not really much of a peak, but it's kind of something called Steamboat Mountain. Do you know anything about that?
No.
Okay, well, look into that. That's something that I've come across. I don't really know a
You're
whole lot
saying
about that.
is possibly there's basalt and Steamboat Mountain that might be some of this,
CRBs,
like what
yeah.
we're talking about is that everybody agrees the CRBs don't have any the elevation. If we can find a flow top in one of the Grand Ronds
Uh-huh.
here, then everybody's saying that that same elevation is here. That this stuff is watery and it's not flowing uphill. But now in the what we do know is that that datum is almost 3,000 feet higher than it
Yeah.
was. That proves that we've had that's conventional talk. But the unconventional talk is that we'd have something like this way the hell up
Remnants.
here,
Yeah,
proving
remnants.
that this thing rode all the way up. Steamboat Rock, the only place that I think I've heard of so far, and I think I found it by accident, was just an isolated little knob of CRB that was to the west of the little town of Eniat.
Oh,
So it's got crystalline core underneath it, and there's just this little remnant. It's like, well,
yeah.
that's kind of funny, and it's only like probably 10 miles from the Columbia River, but just that little microcosm of one little isolated guy means the CRBs had to come 10 miles further west
Yeah.
to get to that spot. And I know people have worked in the high Cascades for the last 100 years, but that's
Not
tough
everywhere.
country up there,
Tough
right? I
country.
mean,
Yep.
is there a mysterious spot or two? And
Well, you're
again,
zoning in on it. I think you're zoning in. That's the right place to look. It's not north of Snoqualmie Pass. It's the southern Washington Cascades for
yeah,
sure. And it's
yeah.
those lumpy hills that rise out of the Columbia Gorge that, the Simcoe volcanics are there. There's some other messy things that people are still a little fuzzy on. Um, yeah, I mean, I look into that. I don't know if there's a story there, but that Steamboat Mountain has come up between
Hmm.
Rainier or between St. Helens and Adams. And also, in your sketch, if you think about that on lap, it's truncated like this in your sketch now, but how much
Yeah.
further, maybe the possibility is that it only went a certain amount further and then encountered topography and on lapped and then shut off. The other idea is that it made it over the crest and made it into Puget Sound, but either
That's
way,
what I
it's going to
want.
be, yeah. And I guess I would say to me, there would be a stronger chance of a valley filling basalt moving it all the way through the Cascades because it would be a thicker flow and it would be an isolated flow and it would shift the river and maybe there's a chance there, but I don't know anything about Puget Sound geology.
That's how we're going to end. We're going to go to one more. Oh, hang on. We're going to go to one more sketch, second camera. And I'm going to read a little bit of Mackin quick. I know you love the old stuff, so I'm not going to bore you with it.
That's great. That's
But
great.
I think the idea is that, oh boy, is so here's the Cascades. This is a map now. Oh God. Come on. This is a map. Ellensburg is here. Seattle is here. And I think you're the one when we chatted yesterday is like, this is a syncline. This is not an accident that the CRBs got through here. We know this is 17 million years ago. We know the Cascades are low, but there's this crinkle cut. It's not there are, as you were saying, Eric Cheney and others talking about these intersecting. There's anticline, syncline like this, and then there's this superimposed Cascade arch. So I think what I'm getting to is maybe there's some sort of middle ground where if the flood basalts didn't overtop the entire Cascade range equally, maybe there were like these secret passageways where there was synclines that, like, I want to find two other synclines, two other secret passageways across the low Cascades in addition to the Columbia River Gorge itself. And is one of them at Divide Ridge, and is the other one at Mission Ridge? And is that a more likely place to look for these guys? So to finish, I will read just a passage that I found here. Thank you for your patience.
Yeah, that's great.
Uplift of the Cascade Range. I mean, this is written, I guess, for a general audience. I love the way he writes this. It's easy to bend a telephone book into an arch, but it's very difficult to produce a simple arch in corrugated cardboard in which the corrugations run at an angle to the trend of the arching. So he's establishing that. Just what we talked about today, because the lava sheets are originally flat, it can hardly be coincidental that the deepest sag in the crest line of the Cascade Range, Snoqualmie Pass, is in a northwesterly alignment with a deep downfold in the basalt flows on the east side, frickin' Ellensburg, Washington, and that the highest non-volcanic peaks, Mount Stewart, are similarly aligned with respect to the upfolds in the basalt, as in the Table Mountain anticline. Again, the implication is that, as might be expected, the general north-south uplift was accompanied in part by minor warping along the ancient northwesterly trend lines. This is 1947, and he's saying that we've got maybe 6 million years of uplift to the Cascades. We have a reasonably clear picture of altitudes and relief before the Cascade Range began to grow. In southern Washington, the basalt plain was not far above sea level. The basalt plain.
Yeah.
And the highest peaks of the ancient granite in the North Cascade stood no more than 3,000 or 4,000 feet. Last thing, many of the valleys on the flanks of the Cascades in Oregon and Washington are steep-sided gorges with scarcely room for railroad or highway in the valley bottoms. But by scrambling up the valley sides, the climber commonly may be rewarded by seeing another valley, widely opened in rounded hills that grade up to interstream ridges and moderate to high relief. There's a reason I'm reading to you. He's going to get to a golf course in just a second, Skye. Here are two distinct generations of topography: a broadly opened surface developed during a period where the stream was cutting downward very slowly or not at all, and a narrow inner gorge produced by greatly accelerated stream cutting. The general effect is that of an enormous rolling golf course, trenched in all the low places by deep gullies. The grass on this scale model is the Cascade Forest.
Yeah, and I put all that in the Pleistocene. All of that entrenchment, all those inner gorges in the Cascades are new.
I just think this might be one of the biggest results of this winter. We've been so focused on the history and the volcanic stuff and the plutons and everything else. That's all important, but I might shift. We might do 2 or 3 letters just on this because I think it's going to have resonance with so many
Mm.
people, and we've been setting it up by mistake, I think, by keep bringing up the uplift thing. I think it's here. This is essentially tectonic geomorphology, is it not? Combined
Oh,
with sedimentary stratigraphy stuff?
yeah. And you've got your caldera deposits, so you've got surface proxy. I mean, you got all the pieces here for telling a story. I would think that Hannah's work and her group's work would comment on the paleo topography at the time that they're working. I think they can forward the ball here and add some clarity. I think there's still a big question mark in that figure we showed early on. Is it 12 or is it 4? There's a big
Mm,
difference. The
right.
Miocene versus, essentially the onset of the Pleistocene, the opening of the Pleistocene. That's a big difference. And I think you got a good shot of finding more basalt farther west than you think, and filling in some gaps. I really, especially in that southern Cascades region, there's more story to tell there, and that's not the sexiest place to work. And, that tends not to attract a whole lot of geologists if it's not that cool to be there. So there's more work to do. Uh, yeah, I'm pretty happy with an age of the Cascades somewhere younger than 10, but it seems like 4 is a little aggressive, and that
Mm.
seems like there was a range here, but how much of a range? Well, who knows? Yeah,
Skye Cooley, I appreciate your time today. Thank
thank
you. I'm going
you.
to let you
Yeah.
go. You hang on the line. We'll talk a couple more
Okay.
minutes when I stop the recording, but I'm officially excited about this topic, and you're a big part of it. So thank you for getting us going here
Well,
today.
thank you
Thank
for
you,
having
Scott.
me. Appreciate it.
Okay. All right. Bye-bye.